All right, let's review some ideas you're going to see on the exam, starting with Chapter 8, Sequences in Series. In number 1, it's asking, what is the fifth term of the sequence? All that means is take the number 5 for the fifth term and plug that in for n. So what you're going to show for work is a sub 5 is equal to 8 minus 5. We're plugging in a 5 for n. 8 minus 5 is equal to 3, and that's it. 3 would be your fifth term of the sequence. Now, number 2 says, for the sequence, we'll write a rule for the nth term. So now you're given the sequence and you have to write a rule. And so probably the easiest way to look at this is that 6 represents you plugging in a 1. So when you plugged in a 1, you got out a 6 in this rule. When you plugged in a 2, you got out a 12. When you plugged in a 3, you got out 18. When you plugged in a 4, you got out 24. So what are you doing to those numbers up top to get the numbers below? And so what the pattern is that you're multiplying by 6. So 1 times 6 gives you 6. 2 times 6 gives you 12. 3 times 6, 18. So when you want to write this as a rule, you have to remember you're multiplying, you're not adding. So your rule would be a sub n is equal to 6n. You can plug in, for example, a 4. 4 times 6 is going to give you 24. So that is your rule for that sequence. Problem 3 says, what number goes on top of the sigma sign in the summative notation for the series? So we'll talk about not only on top of the sign, but we're going to talk about what will go underneath and what goes in the middle. Underneath, it is a safe bet for all the problems you're going to see to assume that it is 1. That just means the first number that got plugged into this rule, which the rule goes here, was a 1. I plugged in a 1 and I got out 0.5. I plugged in a 2, I got out 1. Plugged in a 3, got out 1.5. Plugged in a 4, got out 2. And then we skip some spots, which means there's other numbers that aren't written down, but then the series ends at 10. What did we plug in here to get out a 10? And that is what number you put on top. And so what you have to look is, you have to ask yourself, what am I doing to 1? And it's becoming smaller, it's becoming 1/2. What am I doing to 2 to get it to be a 1? 3 to be a 1.5. So these things are all being cut in half. So there's 2 ways you could really write this. You could write this as 0.5 times n. Really, you could write it as a fraction as well. I just know a lot of times we don't like to use fractions. 1/2 times n. Or even, I'm putting all these ors, so you know there's options, or even n over 2. Bottom line is whatever n is, starting with 1, then 2, then 3, is we're cutting it in half, and that's how we're getting out these numbers in the series. But you have to then ask yourself, what are you cutting in half to get out a 10, the final item of the series? And so what that's going to be is a 20. 20 divided by 2 will give you 10. And so all 3 items are plugged in. Number 4 is now giving you the series notation, and you're going to find the sum. What would these numbers add up to if we start off by plugging in a 3? The bottom tells you what you're starting off plugging in, and then the top number tells you what your final number you're plugging in is. And you have to just go in order. Plug in a 3, plug in a 4, plug in a 5, plug in a 6, and then add these things up once you plug them in. So how that's going to look, now this problem has some work you have to write down, is here is the rule we follow, and we start off by plugging in a 3. So it would look like this. Oops, sorry, left the pencil. 4 minus, not a k anymore, but 3 squared, plus 4 minus, was a k, but we already plugged in a 3, so now we plug in a 4 squared, plus 4 minus, plugged in a 3, plugged in a 4, we now need to plug in a 5 squared. Lastly, plug in a 6. 4 minus 6 squared. And let me move this up a little bit. How we know we are done plugging numbers in is because the 6 was on the top of that sigma sign. So now we need to go through and do these calculations. To start, we have 4 minus 3 squared is 9, plus 4 minus 4 squared is 16. 4 minus 5 squared. Oh, and you know what, on that one, let me fix it. I put the parenthesis. I don't know why I can't erase. All right, I got it. So I erased that parenthesis. I hit it in the wrong spot. It should be on the outside of that squared sign. All right, so 5 squared, 25, plus 4 minus 6 squared, which is 36. All right, now you go through and do all the subtraction. 4 minus 9 is negative 5. You don't really need parentheses. We can keep them if you want. 4 minus 16 is negative 12. 4 minus 25 is negative 21. And 4 minus 36 is negative 32. So now your last step is to add all these up. They're all negative, so your answer is going to be negative, and you end up getting negative 70 for your final answer. All right, all those problems, all 4 of those would have come from 8.1 notes and homework. So if you have to review any of those, that's where you can check those out. Moving on to number 5, this is going to come from 8.2 material. Tell whether the sequence is arithmetic. So arithmetic, you can kind of think of that as the A for arithmetic, A for adding. They should be increasing or decreasing by the same amount every single time. And so when you go and you look at this, the difference between 1 and 4 would be an increase of plus 3. Well, if this is going to be arithmetic, they all need to increase by 3. But right away, we already see 4 to 8 is an increase of 4. It can't happen like that. It has to stay consistent. So this would be a no, not arithmetic. Number 6, write a rule for the nth term of the arithmetic sequence, then find a sub 8, which means you're going to then plug in an 8. So what you're going to use is the rule. Sorry. Let's erase this. Move this back. All right, now we're ready. So what you're going to use is the rule that is written right here. And you're going to need to find a couple things. The first item that you need to find is your difference. How are these numbers that you can see they're increasing, but by how much each time? 6 to a 2 would be a plus 4. 6 to 10 plus 4. Each time these are increasing by 4. So in your formula, the D value will be a 4. So if we write down the rest, AN is equal to, right away we get to what is A sub 1. That's going to be your first number of your sequence. So in this case, right here, A sub 1, it's a 2, plus N minus 1, leave it as an N, times D, which is, we already found that to be the difference between each number, positive 4. From here, we need to simplify this. So you're going to have to distribute your 4. AN is equal to 2 plus 4N minus 4. Almost done with this part. Combine your like terms. The 2 and the negative 4 is going to give you a negative 2. So AN is equal to 4N minus 2. Here is your rule. But now you need to do the second part of the problem, which says find A sub 8. That just means take your rule and plug in an 8 for n. So that will look like 4 times 8 minus 2. 4 times 8 is 32. Minus 2 gives you 30. All right, this next problem is similar to the one we just did in number 6. The only problem is they're not giving you the sequence listed out with numbers. So you really don't know what number A1 is for your formula. But what you have to do is they're telling you that when you plug in a 5, when n is a 5, AN, basically meaning what you get out, is 60. So AN is 60, and that happens when you plug in a 5 for n. They're also giving you the information of what D is, that's equal to 5. So this is how you would solve a problem like this. You have to start out with the formula, which was written on the previous page. an is equal to a1. Now, we don't know this. This is what we have to solve for first, plus n minus 1 times d. So this time we know for when we plug in a 5, an is a 60. So we're going to use that 60, plug it in for an equals a1 we don't know, that's what we're solving for, plus, in this case, because we plugged in that 60, that occurred when n was 5. So you put that 5 in place of n, subtract 1, and d also 5. So we're going to solve for a1 right now. We need to figure out what was that first term of the sequence. And so we're going to move this work up here. We have 60 is equal to a1 plus 5 minus 1 is just a 4, and you're multiplying that by 5 on the outside. That's going to give you 20. So 60 is equal to a1 plus 20. To undo addition, you're going to subtract 20 on both sides, which means that a1 in the sequence is equal to 40. So you're going to need that because now you go back to using the same formula, only we are going to plug in a1. And so an is equal to a1 is 40 plus, go back to using just n minus 1, just like we did in problem 6, times d, which is 5. Now this technically could be your answer, but it's not the most condensed, the most simplified form. So you really need to simplify this so it looks like, so it looks more so like y equals mx plus b. And so what you want to do is distribute the 5. An is equal to 40 plus 5n minus 5. Combine your like terms of 40 and negative 5. An is equal to 5n plus 35. And that is your final answer. You wrote the rule when only given a sub 5 equaling 60 and knowing that the difference was 5. Okay, next problem is finding the sum of a finite arithmetic series. And so what this is actually similar to is problem number 4, only it's going to be using an equation to sort it out and not writing out all that work. And so what you want to do in the equation is you see that you have s sub n, that just means the sum of the series up to n. And in this case, n is 7. And when you look at the rest of the equation, a1, that means we need to plug in a 1 to our rule. And then an means plug in up to what they're telling you n is. And in this case, it's a 7. So we need to plug in a 7. That's what those two parts of the equation represent. So that's what we're going to do. The first thing I'm going to do is plug in a 1 to the rule. This is our rule, and we're plugging it into I. It doesn't matter if it's I or x or n. It's all the same. It's your variable. So 3 plus, so look, I'm finding a1. 3 plus 12 times 1. So instead of an I, I'm putting a 1 because I'm trying to figure out what would this be when n is 1, or I. Technically, I guess it's I. And so this is 3 plus 12, which is going to give me 15. So I need that in a second to plug into my equation, but next up I'm going to plug in a 7. I need to figure out an, and in this case, the top number of that sigma is a 7. So a7 will be 3 plus 12 times, not an I anymore, but a 7. 12 times 7 is 84, so you have 3 plus 84, which is going to give you 87. So we're going to need both of these. So in your formula that's written above, it's the sum going up to 7 is equal to, there's an n on the outside. N is 7. 7 parenthesis a1 plus an, and that was when we calculated a7. So it's these two things, 15 plus 87. On the top, over 2. And so when you plug this into your calculator, you're going to want to do 15 plus 87, which gives you 102. Divide that by 2, you get 51. So 7 times 51 equals 357. That's your answer. It's the shorter way of doing a problem like number 4, using a formula. All right, so those items that we just worked on were from section 8.2, arithmetic sequences. So if you need more information, more practice, go revisit your 8.2 notes. Next up is geometric sequences, which are problems from 8.3. First type, tell whether the sequence is geometric. And so what you're going to do is it's not about adding or subtracting. It's not about looking to make sure they're all going up by 2. You have to do some division. You take the second number in this sequence. Let me move this up. You take the second number in the sequence, which is a 30, divide it by the first, and see what you get out. You get a 6. And you have to do that for each set. So we just did 30 over 5. Now we do 180 over 30. Which also gives us a 6. This is good so far. It's staying consistent. You want it to be the same number every time. So now we try 210 over 180, but this is where we stop because we're getting 1.16. That is not equal to 6, so they're all not the same. You don't even have to check the next one. You know this is a no, not geometric. Next type, number 10, write the rule for the nth term of the sequence, then find A6. Okay, so you pretty much need two things. You need to know what A1 is, which that's easy enough. It's just your first number listed, that's A1. And then you need to calculate R, but essentially we already did that. You have already had practice doing that in number 9. So to calculate R, we take our second number minus the first number, not minus, divide, please, sorry. 16 divided by 8 gives me 2. This is R. That's the rate that our sequence is changing. So from there, all you have to do is put those two items into your formula. So you'd say AN is equal to A1, which was an 8, parenthesis, your R, which was 2, and then your AN minus 1, and leave it like that because then that allows you to plug in whatever you want for N. For example, we have to now, for part 2 of this problem, figure out A6. So A6 would equal, take your formula, 8 times 2, but we're not going to leave the exponent part as n minus 1. We have to plug in a 6 minus 1. And now you're going to simplify this. So 8 times 2, you cannot do that first. You have to do 6 minus 1 in the exponent portion of this problem first. That's going to be a 5. And then now you still cannot do 8 times 2 yet. You have to do 8 and then do 2 to the 5th. 2 to the 5th gives you, I believe, 32. Yep, 32. So now you have 8 times 32, which gives you 256. So that's your answer when you plug in a 6. All right, and number 11, we kind of take it one step further. We're going to still write a rule given a term and a common ratio. So they're giving you R. You don't have to calculate it this time. But now this problem, number 11, it's a little bit like number 7. We don't know what A1 is yet. We know, though, that when we plugged in a 3, that would be our N, we got out a 12. That represents your AN, what you're getting out. And so what we have to do is we have to take these and we have to plug them into our formula so we can figure out what A1 is. All right, so if we can use our formula that we have written right here, AN in this problem is 12. That's equal to A1, leave it there, we don't know what A1 is yet, times R, which they gave us was a 3. And we can, for N, we have to plug in what we plugged in to get out of 12, and that's a 3. So 3 minus 1. Now we have to simplify this. So you do the 3 minus 1 first, which gives you 2. So 12 is equal to A1, parenthesis 3 now to the second. 3 to the second, you do that next. That's 9. 12 is equal to A1 times 9. 2, get rid of your 9 and solve for A1. You would divide both sides by 9. Move this up here. 12 divided by 9 is 4/3. Or I'm okay with you saying 1.3. It's 1.3 repeating. You can say 1.3. That is your A1. Now that we know it, now you can write out your rule because we have A1 and we have our R, and it's going to look now like when we wrote it out in number 10. So you would still use the formula right here, and you would say AN is equal to A1 was 1.3, so you can just use the decimal, parenthesis, your rate, which is 3, and the parenthesis, n minus 1. And then that would be your general rule for that sequence. Last problem for geometric sequences looks like this. And so what we're doing is finding the sum. It's a lot like what we did in number 8. It's just that this is now your rule or equation right here for when the sequence is. This is your rule for when it's geometric, and you had a different rule for when it was arithmetic. It's also really, like I already mentioned before, the same problem that we did in number 4 on the front page, only in number 4 you had to write out all the work. When we did it in 7, when we did it in 8, you had a formula, and now when we're about to do this problem, you have the formula above. So what you have to know about a couple things in here is the 6 here, that represents n, so that's as high up as they want you to plug numbers in. The 4, that's your A1, super important, and 2, what's in parentheses, that's your R. And so how this is going to look is S just means the sum up to n, and we know n is 6. So we'd say S is 6, and we're not even calculating that, it's just the proper notation to write. Equals A1, which is a 4, parenthesis, 1 minus R, that was a 2, to the nth power. N, from the top of the sigma sign, was a 6, over 1 minus 2, and the parenthesis. As when we did these in class, my advice would be to do this calculation on the bottom first, which is going to be 1 minus 2, which is a negative 1. Then the top you can just plug right into your calculator. 1 minus 2 to the 6th gives you negative 63. So 4 parenthesis of negative 63 on the top over a negative 1. Negative 63 divided by a negative 1 is equal to just 63. So you have 4 times 63, which is equal to 252. Final answer. So that completes really all of our Chapter 8 review material. The last couple problems we did, which were problems 9 through 12, those are from the 8.3 material, so you can go check out your notes and your homework for more practice on those. Coming up next will be our statistics chapter, and so we'll review some concepts from there.
All right, now we're going to look at Chapter 11, Statistics and Data Analysis. So we have our data, and the first thing we have to do is identify our outlier. Remember, that's either a number that's very large or very small compared to the rest of our data. So looking at this data set, the outlier is going to be 17 because it is much larger than our next biggest number, which is 10. So then we're just going to find all our measures of central tendency and dispersion using with the outlier first. So we're going to use the 17 in here, and we're going to find the mean. So for the mean, remember, we are just going to add up all our numbers. We get 70, and we're going to divide them by the total numbers that we have. I believe there are 9, and your mean is 7.7. The median, we're going to put these numbers in order from least to greatest. So 3, 4, 5, 7, 8, 8, 8, 10, 17. We cross out first, last, first, last, first, last, first, last. Our median is 8. Our mode is the number that occurs the most. We have 3 8s, so 8 is our mode. Our range is our biggest subtracted from our smallest, so we're do 17, which is our largest, minus 3, giving us a range of 14. All right, next thing we need to do is find our standard deviation. So what we're going to do is we are going to have to get out our calculators, and we are going to have to enter in our numbers, okay? So to do this, what we're going to do is we're going to hit the stat button on our calculator. We're going to hit enter. We're going to go in and put all our numbers in, okay? Once you have all those numbers entered, you're going to hit stat again, hit over to calc, hit enter, 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 enter. All right, and you can see that our standard deviation is going to be this one right here, 3.88. 3.88. All right, now what we're going to do is do the exact same process, but we're going to get rid of that 17. Okay, so there's going to be no 17 in our data this time. So when we go through each of these, we're going to do the same thing, add up all the numbers, but don't use 17. So I think we get 53 divided by 8, and that's 66.6. Our median, this time we're going to have two middle numbers. When you have two middle numbers, you add them together and divide it by 2. We get 7.5. Our mode remains 8. Our range is now 10 minus 3 instead of 17 minus 3, so we get 7. Then we just go through on our calculator and take out that 17 on our list and figure out that the standard deviation is going to be 2.23. All right, then says that we need to describe the outlier's effect on the measure of central tendency and dispersion. So when we added the outlier in, you can see that when all our numbers with the outlier go up, increase, except the mode stays the same. So when we added the outlier, everything increased except the mode stayed the same. Or you could say it the other way around. You could say, all our numbers decreased when we took out the outlier. All right, our next question says, the data set below gives you the total of your tropical smoothie bill in dollars over your last 7 visits. You are so nice that sometimes you pay for your friends, too. Find the mean, median, mode, range, and standard of deviation of your totals. Find the new measures of central tendency and dispersion if each time you went, you had a $2 off coupon. So we're going to do almost the exact same thing as we did above, okay? So first thing we're going to do is add up all our numbers that we have here. It looks like we have 1, 2, 3, 4, 5, 6, 7 of them. Add them all up and divide them, and our mean, you should have got 11.19. Our middle number, when we put those in order from least to greatest, we should have had a 8.56. There was a middle number on that one. There was no mode. No number occurred the most. Our range was 15.71. And when we put those all in our calculators, we should have got 5.16 for our standard deviation. So that was our normal total. So what we have to do now is figure out, it says we have a $2 off coupon. So that means we have to subtract 2 from our mean, 2 from our median. If we had a mode, we would subtract 2 from it also. We're not going to do anything to our range or standard deviation. Those are going to stay the same. So when we subtract 2 from these, we get 919 for our new one. Our new median is 656. This will not be affected. These stay the same, 1571, 516. So now it says, in reference to the question above, describe the coupon's effect on the measure of central tendency and dispersion. So it looks like our mean and median decreased while our range and standard deviation stayed the same. All right, on the back page, we're looking at normal distribution. So the formula we're going to be using to do these, let me zoom in a little bit, is going to be Z equals V minus the mean. V is the number of interest divided by our standard deviation. So it says the scores on a standard test administered to 10,000 students. We don't need to know that. The mean is 50. We're going to put that symbol there. Our standard deviation is 10. I'm going to put that there. So it says what percent of students scored below 50? That is our V. First thing I want to do is my bell curve by putting a 50. It says below 50. So our line's going to go straight up and down, and we want to know below 50. So I'm going to shade it to the left. And I'm just going to write X is going to have to be less than 50 also. All right, let me zoom in here a little bit. So we're going to plug in our numbers to our formula. All right, so we're going to plug in our numbers into our formula. So we're going to have z equals our number of interest, which is 50, subtracted from our mean, which is 50, divided by our standard deviation, which is 10. So 50 minus 50 is 0, divided by 10, so our z-score is 0.00. Now we're going to go to our z-score table, and we're going to look on the outside. Okay, so let me grab my z-score. Let's see if it's this one. Yep, it's this one. So if we zoom up here, and you can see that 0, 0 is, let me get red here, 0, 0 is right here. So 0, 0, 0 is right here. So we're going to have 0.5000. So let me zoom this out of here. So I'm going to write equals, once we use our table, I'll write table here, we're going to get 0.5000. We change this to a percent, so we move it over 1, 2. So what we get is 50%. Now it says below, so we don't have to do any subtracting from 100. This is going to be our answer. All right, I'm going to jump to C because we're going to do C basically almost identical to how I just did A. Okay, so it gives us a V again in the problem. So I'm going to put V here. I'm going to fill out my chart as a 50 here. It wants to know above 75, so I'm going to put 75 over here. I'm just going to shade to the right. So we're looking for a number that is above a 75. Okay, so now we plug in our numbers just like we did at A. Z equals, this time it's 75 minus 50 divided by 10. Okay, when we calculate this, we get 2.5. That is our z-score. We're going to look on the outside of our table. So let me grab my table again and try to find 2.5. It's not going to be on that one. It's going to be on this one. So I'm going to zoom up here. We're going to find, I'll get it real big here. Here we go. So I'm going to look on the outside and find 2.5. Here it is, right here. So I have 2.50 because there was no number after that. I could put a 0 there. So it's going to be this number right here. So it equals 0.9938. All right, let me unzoom on my z table here and throw it over here. Oh, I wrote it on the wrong thing. Let's write it. So it's 0.9938. So we go over 1, 2 times to the right, so we get 99.38%. Now we're not done, okay? This is not our final answer. I shouldn't even be circling it because the problem says above. And whenever you see the above, you have to subtract from 100 your final answer. So we're going to do 100 minus 99.38. And we get our final answer for this to be 0.62%. All right, let's look at the second type of problem that you have. Now these ones, it says for B, let's go to B. It says, in order for a student to fall in the top 20%, what is the score? So this time they give you a percent. So let's do our bell curve. We're still going to put a 50 in the middle. This says top 20%. So we're going to just shade in the top area here, and we're going to put a 20%. Okay? So we're still going to use our same formula, but we have to work backwards. So it says top 20%. So whenever you see top or above, we're going to have to subtract from 100. So we start by going 100 minus 20. That's going to give us 80%. So now we change 80% to a decimal. We move it over 2 times. We're going to 0.80. Now at this point, we're going to have to get our z-score tables out. And we're going to have to find 0.80 inside the chart. So I'm going to grab my z-table. Try to zoom in on here, and I am going to try to find the closest I can to 0.8. So looking in here, let me look a 0.8. Okay, I think right here is pretty close, okay? 0.7995. So then I work backwards. So I go out this way, that's 0.8, and I go up this way, 0.04. So what our z-score will be is 0.84. So let me zoom this out. All right, so what we'll have is 0.84 equals V. We're going to keep V in the formula, minus 50 divided by 10. All right, so now we have to just solve this. I zoomed in here. I want to multiply 10 on this side, multiply 10 on this side. That will cross out the 10s on the right. 10 times 0.84 gives us 8.4 equals v minus 50. Now it's a one-step equation. We just have to add 50 to both sides. We get our final answer to be v equals 58.4. And that makes sense when you look at the chart that 58, if you score a 58.4, you're going to be in the top 20% of students. All right, the last one of this type, it's a percentage one. This time it says, in order for a student to fall in the bottom 10%, what did they score? So this is D. We have bottom 10%. It says bottom, so we don't have to worry about subtracting from 100. We're just going to straight up change this to a decimal, 0.10, and we're going to go and find our z-score using our table. So I'm looking for the closest thing to 0.1 on my graph. So I think I'm going to have to use this top one up here. Yep, so we're looking for the closest thing to 0.1. Let me use red here. 0.1. 0.10, probably either, you could go either one of these two. I'm going to go with this one right here. So then I work backwards, and I get negative 1.2 going straight up 8. So I get negative 1.28 equals v minus 50 divided by 10. So now we're going to solve it just like the one we solved above. We multiply 10 by each side. When we do 10 times negative 1.28, we get negative 12.8 equals v minus 50. Then we're just going to add 50 to both sides, plus 50 plus 50, and we get our final answer as v equals 37.2. All right, our last set of questions says, a newspaper is sponsoring a poll and wants to find out the preferences of people across the state regarding the governor's election. So across the state is pretty important. The newspaper surveys people by leaving a questionnaire card at grocery stores for customers to fill out. Okay? It says, identify the type of sample. Well, it is a questionnaire card, right? So people have a choice whether or not they want to fill it out. So that's going to be called self-selected because it's voluntary. And it says, is the sample biased? Why or why not? So I think that this would be biased because they're only asking people in grocery stores. So that because they only ask people in grocery stores. The next one says, in a survey of 600 U.S. adults, 81% said that they have purchased products online. What is the margin of error? So our formula for margin of error is 1 divided by the square root of n, and there's a plus or minus in front of it. So all we have to do is 1 divided by the square root of the amount of people they asked. So in this case, it was 600. We type that into our calculator, and we get, what is it, 0.0408. We change it to a percent by going 1, 2 times to the right, so our answer is plus or minus 4.08%. Number 20, give an interval that is likely to contain the exact percent of U.S. adults who have purchased a product online. So we're going to go back up to the question here and use our 81%. We're going to do 81 minus 4.08, which we had on the answer as the question above, and 81 plus 4.08. So on the top we get 76.92. And on the bottom, we get 85.08. And we just write it as an interval by doing the smallest number first, 76.92%. And we put a dash, and then we write 85.08%. Last question. A survey claims that 35% of high school students prefer having gym class during the last period of the day. The survey reports a margin of error of plus or minus 4%. How many students did they ask? Now, we don't need this 35%, but we do need our margin of error. So we're going to do the opposite of what we did for number 19. We are going to take 1 divided by, we change our 4% to a decimal, which is 0.04. And instead of square rooting, we're going to square it. So 0.04 squared. Type that into your calculator, and I think we get an exact number for this. We get 625 people.